Hey everybody, David Tushin from Check Ride Prep, and I'd like to share with you a video that we created during our live online private pilot ground school. Now, over the years, I have seen plenty of students not really have a grasp or a good understanding of the VOR system, and they start to confuse the terminology and how it works. I've seen this both on the written test and then also as people are preparing for their check rides, they don't have that foundational knowledge. So what we've done is we've put together a video for you to talk about the basics of the VOR system and how you're actually going to use it for navigation. So we'll take you through the steps of understanding how a VOR actually works. In addition to that, we'll go through tuning and identifying a VOR, tracking radials inbound and outbound, and we'll also talk about the practical purposes of navigating from point to point using a VOR. So with that, I hope you guys enjoy. We're going to be doing, as mentioned, is we're going to be using the VOR Simulator. For those of you, I gave this link in previous classes and also the class the other day. So this is the Luiz Monterio, if I'm pronouncing that correctly, .com. They have several different simulators available, but it basically looks like this when you pull it up. Make sure if you are using it, you have Flash enabled. For most of us that are using Chrome, I don't know, at least I use Chrome a lot. There's usually like a little lock in the corner there or a little info button. If you click on it to the left of the web address, what will end up happening is that will allow you to enable basically the Flash for it. The thing that we're primarily going to be paying attention to today, though, is I will kind of go through this real briefly. Our airplane, as it relates to the VOR, is right there on the left-hand side. And then obviously our VOR is this guy right there. So we are going to be using a VOR DME. And the thing is that this kind of allows us to look at it in a 2D environment, basically a top-down view, if you will. And the things that we're going to pay attention to is we're obviously going to be using our VOR in the center, and you'll see me basically spinning the OBS right there. So that's basically going to spin the movable compass card at the top, right, and left, and that will then change the to and the from indication. The other thing that we'll also be paying attention to is in the very bottom here, this is the DME. Looks like a football playbook. Let me see if I can clean that up a little bit. Down here, this is the DME. So as you can see in this snapshot, this is 9.8 nautical miles from the VOR. So obviously, a lot of times people ask, well, am I going to the VOR or am I going away from the VOR? Well, if the number gets higher in terms of your miles are getting higher, you're running away from the VOR, okay? If it's getting smaller, then what's going to end up happening is we're going to the VOR. Now, I'm going to show you how to track and intercept a VOR, and I'll also show you how to go direct to a VOR. So in the event, I'm going to basically point the nose of the airplane, probably going in a different direction, completely away from the VOR, and I'll show you how to then track directly going to the VOR, okay? After that, we'll also look at reverse sensing, and I'll describe why when we're going to a VOR, we don't want to have a from indication. So anytime we're tracking to a VOR, we're actually tracking a bearing, and anytime we're going away from a VOR, we're tracking a radial. So that's something to keep in mind as well. Now, if you want to practice this on your own, there's obviously keyboard commands. The majority of what you would use is in this green sector, WASD. And then if you wanted to increase your speed, it's basically K and M, but just try to follow along. You don't need to do it simultaneously. Otherwise, you're going to miss the concepts that we're going to be talking about today. All right. The other thing too is that we will basically try to show you, how the needle will move right and left to the center of the donut. And remember, once it kind of touches that donut, that is when we are going to start to make our turn inbound. But those would be the primary things that I want you to pay attention to. Other things that we're really not, the things that we're primarily going to use today are going to be the VOR and also the heading indicator or the DG. Everything else we don't really need. We don't need the turn coordinator, the airspeed indicator, or anything else. It's just the concept of how these instruments work, all right? So that's what we're going to be covering today in the first part. The second part, we'll be going through the aviation weather. So with that, before I forget, I'll share the METAR and TAF decoder as well that some of you already have. You can look at that, download that, and we'll be using that for the second half as we continue along. All right, so let's just do a brief review of VORs. So remember, VORs, if you want to think about them, they're kind of like bicycle spokes. So at the center is where the VOR lives. And coming off of that VOR, there's 360 radials that basically are radio signals that are transmitted in all directions. Now, those radials will get further and further apart the further that you get from the station. So what we say is, on average, an average VOR, if we were to look at it and we had a VOR here and a VOR here, and the average VOR is only going to be about 40 miles away. Okay, so that it will only travel for about 40 miles away. But to give you an idea of potentially, for some people that like this stuff, if you are 60 miles from the station, and I'll put this in writing so you can see it. So if you are 60 nautical miles from the station, the distance between these two radials, so I'm going to call this the 090 degree radial, and I'm going to call the bottom one the 091 degree radial, okay? The distance between those two radials at 60 nautical miles is 1 nautical mile separation, okay? At 30 nautical miles, if we were to half that distance, then you're basically just going to half the number. So the distance between those two radials would then be 1/2 of a nautical mile, or 0.5, okay? That would kind of give you an idea of the distance in terms of how far they go. Now, generally, what we say is that VORs are usually good for about 40 nautical miles, although there are some circumstances where they are good for further, and it also depends on your altitude and the type of VOR. Once again, talking to the private pilot class, this is something that we get into more on the instrument side, because VORs actually have what is known as a service volume, and the service volume dictates it dictates how, the strength of the transmitter and how far out that it actually reaches, and it's also based on the altitude. So there's 3 different types of VOR transmitters, if you want to think about them that way in terms of strength or power. We have a high, a low, and a terminal. So those are the 3 different types, okay? So going back to the chart here, just making sure everybody understands. My writing has dramatically improved. Thank you, Bruce. It's because I'm just doing lines. I know what my limitations are now. So anyways, with the VOR radials, as mentioned, if we were to look on an actual sectional chart or tack chart, as we can see here, we have, we do have the Ventura VOR, which is right here. And the Ventura VOR, we can see the frequency of 108.2. So that's the frequency that we're going to put into our navigational radio. Channel 19 is referring to the military channel, so we don't actually use that. And then the VTU is the identifier for Ventura. So remember, the way that we read Morse code is from top to bottom, and it's from left to right. So if we were to look at the very first line of the Morse code here, it's ... dash. That refers to the V in Ventura. The T is the next line, which is just a dash, and then the U is the final line, which is the ... dash. So you don't need to memorize Morse code. This is just, you would look on your sectional, and the very, very first thing you always want to do is what we call tune and identify the VOR. Make sure that the VOR is actually working. Make sure that you have identified the correct station. That's one that students miss a lot, where they've got fat fingers, and instead of putting in 108.2, they might put in like 107.2, and 107, or 109.2. That might be a completely different VOR somewhere else on a different part of, it might be Van Nuys or something like that. Now, the line underneath the 108.2 indicates that there is no voice communication or services available on this frequency. Remember that certain VORs have the ability to receive information from flight service stations, or allow you to have two-way radio communication between flight service stations. So that is the whole purpose of that. If the line was not there, then that means two-way radio communication, or at least voice communication, could occur. So the other thing to note is that we do have the compass rose, and the compass rose points always magnetically. So as you can see here, we do have the 0 mark. The 0 is actually pointing to magnetic north. and then we have the compass rose that goes around it. Anytime that we have a question, what you want to do is pull out and really kind of focus in on when it says go direct from an airport. Let's say we're going direct from Point Mugu Airport, and we are basically going to go direct to the VOR. If I extend that line out from Point Mugu Naval Air Station through the VOR, what I am paying attention to is where that line intersects the compass rose. So we've got 060, which is right there. We have 070, and right here is 080. So it's probably somewhere between 075 and 080. That would be the answer that I'd be looking for on the exam. That's what we're doing on the zoomed in version. So keep that in mind, is we're looking at where that line intersects on the compass rose, and then understanding where we're coming from. Do we need to look at, is that the answer, or are we looking for the reciprocal value? Remember, the reciprocal value is just the opposite number. You can either add or subtract 180, or you can do the +2 -2 thing that I showed you in class. It works for 90% of the numbers out there. There's a couple that it does not work for. All right. So that is VORs in a nutshell. So let's go through the actual radials. Remember that the radials only go, they go in all directions, but you can't, they're just like freeways if you want to think about them that way. For example, if you are going to be traveling in your car, we'll look at the middle one here. So with this one right here, okay, I am northbound on the 180 freeway, all right? The town is representing the VOR, and if I continue past that, I'm basically on an interchange, and that interchange changes to the freeway, the 360 freeway. So that is actually representing the 360-degree radial. So this port, this top part, this radial that's basically sticking out of the VOR, which basically goes up, that is the 360-degree radial. The one that's going straight down is the 180-degree radial. So if we are basically south of the VOR, we are tracking the 360-degree radial, but we're on the 180-degree freeway or 180-degree radial, if you want to think about it that way, okay? Now, the way that we manipulate what radial we're choosing or what course that we want to follow or find is using that OBS. So we can twist that OBS, and that compass card will move right and left. Now, the other thing that we're also looking for is inside of that little white box there, we're going to have a to, a from, or we could potentially have the word off or a barber pole indication, basically indicating that it doesn't have a good signal, or we're kind of in that cone of confusion, if you will, when we're overflying the VOR. So if we look at it just as a standard airplane here, this airplane is on the 180-degree radial, but it is tracking the 360-degree radial, that pink line just north of the VOR. The reason why we're tracking that line, if you will, is that we want to always go fly to the VOR with a to indication. We never want to fly to a VOR with a from indication. Now, some of you got confused the other day when I said if you just flip the numbers. So what I mean by that is that if this said from an FM, all you need to do is flip whatever's on the bottom and put it on the top. So you can see how 180 is on the bottom. I would just put the 180 on the top and move the 0 to the bottom. That's all we mean by flipping the numbers. It's taking the reciprocal. The other thing too is that if you didn't want to do any math or anything like that, all you can do is just you can look on your heading indicator or anywhere else. You can basically draw lines and figure out what the reciprocal number is. So, you know, the opposite of 60 is 240 if you didn't want to add or subtract 180 degrees. So that's one option that you have as well. Now, for the purposes of what we're going to do today, like I said, I'll show you how to track to a VOR with the correct indications. Remember, whenever we're going to it, we want the to indication. Whenever we're flying away from it, we want the from indication, okay? All right, so let's see. As we're approaching the VOR, what will end up happening is we will get into the cone of confusion. The cone of confusion is effectively where we are going to see the CDI start to move one way or the other, and it will start to move erratically to the point that it will kind of swing in and out, and then eventually we'll either get the off symbol, or what will end up happening is we will get the barber pole, if you will. So the barber pole or the off is just indicating that it doesn't have a signal. Now, the reason why this is occurring is the fact that we've got 360 radials that are basically converging in one single location that the receiver is getting confused. It doesn't know which of the radials you want because there's so much information. So we can't say if the VOR is going to swing out to the left or to the right. It's very random when it does it. But what you want to do is you don't want to chase the needle when you're approaching the VOR. Usually that's about a half a mile or so. You want to make very small corrections, if anything. So whatever your correction is, and this is in a no-wind environment, the one that the author is demonstrating to you, we just want to maintain our heading of north. And as we maintain our heading, what we're looking for is that once we get a little bit further away from the VOR, that VOR will then come back to center, as long as we weren't blown off, of course, or sometimes it might be maybe just slightly askew where we can make a small adjustment and then basically make a little bit of a right turn in this example and move that back into the center portion, okay? Assuming everything was good and we basically continued on a northbound heading, now what we are is, remember that this is the 360-degree radial if you want. So we're on the 360-degree freeway if you want. And Kim, yep, it will automatically switch from the to indication to the from indication automatically, right? So it automatically will switch. Once it gets out of that cone of confusion, remember, there's a couple limitations for VORs. The first limitation is going to be line of sight. So the VOR, if there's any type of terrain or anything along those lines that will interfere with that line of sight, then obviously you can't pick up the VOR signal. The other thing as well is the cone of confusion that we're talking about right now. And then the third thing is that we'll talk about is going to be reverse sensing. So if I were flying away from this with the incorrect from or to or whichever way I'm going, then the airplane will basically give me incorrect indications, okay? So hopefully everybody's good with that so far. That didn't confuse anybody. What we're gonna do is we have our airplane pointed here. I have everything set up the way I want it to be. And in this case, I want to track the 030-degree radial. So my goal is to track that green line on the opposite side of that VOR. So I am going to basically try to get onto this blue line, which is the 210-degree radial, which is the reciprocal of 030. So what I have set up at the very bottom, if you look in the VOR, is I've got 030 set up. My airplane is going to the station, which is what I want, and I've got the triangle with the to indication on the VOR. Now, the only thing I need to do is figure out how much do I want to turn the airplane in order to intercept this line. Now, with everything set up, you'll see that the CDI is off to the right, and because it's off to the right, that means that my line or whatever I'm trying to intercept is off to the right. So if I go ahead and start this guy up right here, you'll start to see my airplane is moving. And what I'm going to do is I'm going to make a bank to the right. See if I can make this not very severe here. So right now we are crabbed in and we are trying to track. As you can see in the VOR needle is slowly starting to swing in, okay? As it approaches the center, what I want to do is then make that turn back to 030. So my heading indicator, I'm going to go ahead and bug is 030. And at this point, I'm going to slowly start to make that turn. I don't want to overfly past it, even though I probably will just a little bit. Shows you how good I am at computer simulations. So in this case, if I was fighting the wind, I am going to basically try to fly just slightly to the left of 030. And I'm going to still see if I can center that back into the donut. So you can see that the needle is starting to come back in. And I'm making a right-hand turn back to 030. And in this case, now everything's looking good. So my CDI is perfectly centered in the donut. We can look at our DME at the bottom. I'm 2 miles away, 1.8, 1.7. I'm expecting to get inside the cone of confusion. Now, the closer I get to the VOR, the more sensitive it is. Now, in this case, there is no wind, so that's the cone of confusion. We saw the needle basically swing out, and now it's starting to swing back in. I have a from indication at the bottom here, so I know the VOR is behind me. If I look at my DME, my number is increasing. There's 2 nautical miles, 2.2, 2.3. And now, as a pilot, I can just make small corrections. So if that needle is slightly to the right, I can come just ever so slightly to the right and see if I can intercept that, and then basically make small adjustments as I am moving through the system. All right. So that is what it would look like if we're tracking and intercepting a radial or a VOR in this case, however you want to call it. All right, when we are flying direct to a VOR, all we want to do is, it's a couple easy steps. Number one, we always start off with tuning and identifying your VOR. Okay, that's going to be your first step. After that, what you're going to do is, once you have your VOR tuned and identified, you want to then move your OBS in order to get, you want a 2 indication with your CDI centered. Okay, that's the next step. Number 3, what you're going to do is, whatever that number is at the top that gave you the CDI, that basically allowed the CDI to be centered, that is a number that you're going to turn to. So you're basically going to turn to the heading, the initial heading if you want, and we find that at the top of the VOR because that's what is set. And then the final thing that we do is we are basically getting 1 additional twist, and I'll show you what that is to ensure that you're on the radial. Okay, so we always tune and identify the VOR. From that point, we are going to twist the OBS in order to get a 2 indication with the CDI centered. Whatever the number is on the very, very top with the needle centered, even if it's 1, 1, 1, that right there, whatever that number is at the top, that is what I turn to. That is going to be my heading. So I plug that in, and I want to make sure I turn to that. And we'll talk about the 1 additional twist, but that's just, you get 1 additional twist of the OBS, and that additional twist is to center the needle, and that will tell you what radial you're currently on. Okay. So my airplane is effectively moving all the way away from the VOR. And if I don't know where the VOR is located, remember this airplane is equipped with DME, so I can utilize the DME, which is at the bottom center of the screen here. The very first thing that I want to do, and I'm going to slow this simulation down just a little bit to 2x so everybody can follow along. So the airplane is now effectively on a heading of about 111, all right? So it's heading south, as you can see, or south-ish, if you want to call it that. The very first thing that I'm going to do is tune and identify this VOR. So once I listen to the Morse code and identify that it's the correct one and it's working, then what I'm going to do is I'm going to be able to take a look at my VOR at the bottom, and I want to go ahead and twist my VOR until I get a 2 indication with the needle centered. All right. So if you do this, this would be incorrect because this is a from indication with the needle centered. So I need to put that number at the bottom, basically on the top. So I'm going to keep twisting it until I have a 2 indication. And obviously you can do this a lot quicker in the airplane, but I'm just kind of showing you what this is going to end up looking like. So as I get it, you'll notice that it did flip from a from to a to. Now what I'm going to do is I'm going to keep twisting until I can actually get that needle roughly centered. Okay. So now that that needle's centered roughly on 259, now what I'm going to do is I'm going to make whatever the shortest turn is to get to 259. So in this case, I will just kind of make a long roundabout right-hand turn here, and I will bug my heading of 259, which is the red dot. So there's 240, 250, somewhere in here. Okay. So there's 259. Now, as I make that turn, I am turning to whatever the number is at the very top of the VOR that I basically dialed in, which we can see the top number is 259, which is what we have in the OBS. All right. Now, this is, of course, accelerated. So this is exaggerated what's ending up happening here. But as I make that first turn and I come around to the VOR, my airplane is coming around, and what I'm going to do is I'm going to level my wings roughly at about 259, 260-ish, okay? So as I level my wings, what ends up happening is that I basically overshot the radial that I was looking for. So in this case, what I get, and that's 259, that's where we're at, is I get one more twist, and that will tell me the radial that we're currently on. So in this case, the radial that we're currently on is the 269 degree radial. We have a 2 indication, and we can now see the DME is starting to fall. We're getting closer and closer to the station. And then it's my job as a pilot, in order to keep this needle centered inside the donut. If it starts to slide away, right or left, then all I'm going to do is make those correct choices depending on what I'm trying to do, or if I don't want to chase the needle in that case. All right. Does everyone understand how we did? You don't need to actually be flying to the station to utilize the VOR. If you want to know what radial you're passing, I'm going to put the airplane at 360 degrees, so it's going to be directly going north now. Now, this airplane is going to go north, and if I want to know what radial I'm passing, this is something that we do in the instrument world, because what we have is there are some approaches called DME arcs, and what a DME arc is we basically arc around a VOR, and then we fly inbound to get to an approach, okay? So the reason why that's important is we need to know what radial we're currently passing. So what I'll do is, you'll notice that the way that I have the VOR currently set up is a 2 indication, and why the needle is to the right is it's showing that the VOR, or that radial, is in front of me. As we pass the radial, the needle will start to swing to the center, and then it will start to swing to the left, okay? As we do that, I'm going to move the OBS again, and then I'll move it back so that way the next radial is in front of me, so we can see all of the radials that we're passing as we go along. Now, the first radial that we're looking at is going to be this one right here, which is going to be the 256. So that's basically extended off. All right. So in this case, what we have is, I'll show you in the simulation. So I'm going to go ahead and start this guy. You can ignore the airplane going around the Earth. So we're about 20 miles away from the VOR. The big thing that I would say is that we are heading slightly, not northbound. We were heading northbound. So let's see if we can head northbound again. And you'll see that the VOR needle will start to kind of swing in, okay? So as it swings in, we are not going to the station, but it is telling me what radial we are going to be passing. So when that CDI is perfectly centered in the donut, that means that we are passing whatever the radial is at the top, which is basically that blue line. So that CDI, because it's to the right of the airplane, means that it is in front of us. Now, once again, that's a higher concept that you learn in the instrument class, because you have to do DME arcs, or at least learn about DME arcs. But if you were not using, as I think it was someone said, if you're not flying direct to the station, you can basically utilize it to see which radial you're either on. So for example, that's the radial that the airplane is currently on right this second. Any questions about that? And as we can see, that needle is starting to swing further and further to the left, which means we're passing that radial. Now, if I wanted to know what the next radial is, I'm going to go ahead and, let's say I'm going to spin this, and I want to know, when are we going to pass the 240, okay? And remember, what will end up happening is it will start to swing in again. And either way, you just need to know which side of the radial you're on. How do you know you're 20 miles away? So in this case, this airplane has a DME, so I'll go ahead and point to that. That is right there. So that 28.9 nautical miles is how far away we are. So we're actually getting a little bit further and further away from the VOR at the moment, okay? So as we approach this radial, it will slowly start to swing in again, and as it swings in, it'll go to the donut. When it goes to the donut, that's the radial that we're basically passing or we're on, and then it will start to swing further to the left. So you can use it in other fashions as well. Remember, don't make it more complicated than you need to. It is not required for the FAA exam to show this, at least for the private pilot, all right? Hopefully that kind of clears up how to use the VOR. Hopefully that will make a little bit more sense. It's the same concept, Jim. Yep, same concept. When you're flying to a VOR, have a to indication. When you're flying away from a VOR, have a from indication, okay? What I encourage everybody to do is try out this simulator now that you guys, what we said is that anytime that we are going to the VOR, we never ever want to go, I'm gonna put in 240, we never ever want to go to the VOR with a from indication, okay? So in this case, I'm gonna go ahead and flip the indication so that way it has a from indication, which is the green side here. And remember, everything on the left there is primarily just for your reference. So I'm going to throw in about 0. I'm going to make it easy, just 060. So as we can see here, I'm doing what we should not be doing, right? So I've got a from indication right there, and I'm going to a VOR, which is the no-no, all right? So what I'm going to do is I'm going to start the simulation here. And if I were to actually follow the needle, you'll see that the needle is now showing me that I need to go to the left in order to intercept. So what I'm going to do is I'm going to make a slight turn to the left. I will basically make a left-hand turn to 210. And as a pilot, if I don't know what's going on, I'm just thinking that there's a significant wind that keeps pushing me further and further and further off course, because now I'm basically just crabbing, okay? So now I'm just going to level the wings, and this is what we call chasing the needle. This is what we call reverse sensing. So as you can see, the airplane is getting further and further away from that green line, and that green line is representing the radial that we're tracking inbound to the station. And yet my CDI is getting further and further away. So most pilots at this point, they start to get a little bit concerned. They start to turn even more. Let's say we're going to start to turn to a southbound heading of 180. And now they notice that, well, that's not really working. The needle is just still not behaving. It still keeps going further and further to the left, and they don't want to get a full-scale deviation. All right, so that's what happens when reverse sensing. If I make the turn back and I want to try to get back on course, the course that I would initially try to use is going to be whatever is at, whatever's kind of at the top here. So let me go ahead and try to make a turn back the other way. So if I make a turn back the other way, maybe I can get this sorted, okay? But do you see how that works, where you have to kind of reverse your thinking in the sense of when we are in reverse sensing, that is where we can get into some trouble using the VOR system, okay? So now I'm turning back to the right, so I'm kind of almost heading slightly back to the west here, and this will actually start to swing in, which is contrary to what we have. Now, if I wanted to correct that, all I'm gonna do is instead of the 060 at the top, I'm gonna put the 060 at the bottom. And that would then give me the correct indication. So as you can see, if I put the 060 just right about there, we've got 060 at the bottom, 240 at the top. Now we have a to indication. Everything is looking a lot better. And in a no wind condition, the top of the number on the VOR and your heading should be equal, okay? So that would be just like this. If I bug 240 and I slowly start to make the turn, remember you want to lead your turns because the airplane is moving fairly quickly. And as you do that, that needle is going to start to swing in towards the donut, and you can do a small crab, for example, and then it will start to come in, okay? So hopefully that makes a little bit more sense in terms of what reverse sensing is and the reason why we want to avoid reverse sensing.